I'm from Bank 2 S3. My name is Pavitran. Today I'm going to talk about BJT, resistor and capacitor. Basically this is an introduction on all these three things. Okay, I'll start with BJT. BJT's long form name is actually bipolar junction transistor. Okay, bipolar junction transistor was made on 1948 by Shockley. Okay, it was invented by Shockley on 1948. Okay, the place where it was actually found or invented was actually first on December 1947, which is the first name known as bipolar point contact transistor at the factory laboratories of Bell Telephone by John Bardeen and Walter Britton, but it's still under the direction of William Shockley. But later on, William Shockley changed it to BJT, which is on 1948. Okay, one interesting fact is that it is 3 decades the device of choice in the design discrete and integrated circuits. Nowadays, the use of BJT has declined in favor of CMOS technology. Okay, next is that we will go in detail with the BJT. Actually, BJT we got two types of transistor, which is P-junction transistor and N-junction transistors. Okay, to be detailed is that PNP and NPN junction transistors. Okay, what is the actually function of transistor? It's actually to amplify the waveform of voltage or current, which is we can see in the difference ratio of voltage gain. Okay, that's for the transistor. Okay, next we will move on to resistor. Okay, resistor, as we know, resistor is actually to minimize the flow of current and voltage in a circuit. It's actually current, but it's actually to amplify the voltage. Okay, resistor is mainly used in a lot of circuits, even in a lot of electronic components, electronic devices. Okay, however, resistors are nowadays quite less used because in time there are circuit IC boards that have started to having its own resistors. So pretty much resistors are quite less due to the actions. And next we can move on to capacitor. Okay, capacitor. Okay, capacitor, the definition is that is to store electrical energy in an electrical field. Okay, basically it's made out of two depletion areas of surface, and in the between is the place where the current is stored. Okay, capacitor is actually one of the considered thing that we can never change, because for now there are no components that can substitute capacitor. Even though we use IC circuit may substitute other components, but it can never substitute capacitor, because capacitor is something that only can store current. It's actually more to towards same as inductor's function, which is uses electromagnetic field to save voltage. Okay, other than that, capacitor, we know that capacitor has the use of storing current, and for the circuit it's actually considered the same thing, because it stores the current and then it amplifies the circuit wavelength that we will find in the function gen and oscilloscope.
Okay, hi guys, my name is Satya from 2 Bank S3.
Okay, now we have a look about the theories. So we're gonna see the circuit and PCB layout, and also 3D printing for printout in a PCB. So let's go to the etching process after this.
We have done printing, so we got the layer and we got the PCB board. Now we're gonna go for UV etching. Okay, let's go inside. Okay guys, okay, since we can't do this process with the light open, but we're going to show you the demonstrate sample how we're going to do. Okay, first of all, this is the unit of known as the vacuum expo unit. Okay, first of all, we open this thing, and there's another one more layer over here. It's a plastic layer. We open it. Okay, then we take our this thing, put onto the PCB, place it over here. Then we close the first layer of sheet, and then first press the vacuum. Once we press the vacuum, it will vacuum air over here, the bubbles all, and make sure it sticks. Then we close this the last one, and we press these 3 buttons, 1, 2 and 3, and wait for the to hear the beep song. Once the beep song is heard, we open back And make sure you close these three things first, then open the second layer, and then we can see there's a pattern over here, but we can't see over here. We need to go to the etching room to do that.
There are several safety measures that we have to follow before we start our etching process. So these are the equipments that we have to wear, and then first of all we have to wear the goggle, and then a mask, and then gloves, apron, and safety boots to ensure that there is no acid split on ourselves. Okay, let's go for the etching process.
Okay, once we done the UV etching, now we're gonna put this PCB there inside the chemical and soak this for 15 seconds. And then once done soaking for 15 seconds, we take it out and we rinse with the water, and we repeat this step until the PCB there turns to green. After done this, we will go to this machine known as Mega Electronic. What the fuck? Okay, once done with the chemical part, now we have it moved to the conveyor spray. This one we have to put over here. Come over here, please. Okay, we put the PCB ball layer here, and it will go inside. This process we need to repeat for 3 times or more than 3 if there is still copper. The copper is inside on the PCB. Okay, once this thing is done, we go into the move to the conveyor dryer into outside that. Before me. Okay, this is the conveyor dryer which dries the PCB. First of all, we have to open the switch over here. Okay, and turn to 50 and put the PCB right over here. Okay, then if we come outside over here, we have to repeat this more than 2 to see whether the PCB is dry or not. Once dry, we can proceed with the drilling and cutting the PCB white.
Now we are done with etching process, so we are here in front of the drilling machine. We're gonna drill this board to make the components legs fit in correctly. So yeah, this is how we have to drill it. We have to do it much more precise. Okay, that's how we do it. After we're done with drilling process, so now we're gonna solder the components leg in the circuit, and this is the equipment that we are using, and there must be a hose to take the smokes. Hi, okay, my name is Arvin from 2Bank S3. So we're gonna do lab 3. Let's go. Okay, this is the circuit whereby previously we was doing etching and soldering, and we was drilling using this. So this is how the component sits up, and this is how it has been soldered. So we have 2 wires connected here for the output of the waveform of this circuit. Okay, let's go and see how does the circuit works. Okay, hi. So we're gonna do common base configuration today for BJT, and here is our circuit and setup here. So as we know, BJT is bipolar transistor junction, transistor, and then we are doing a common base configuration setup. So it is one of the 3 basic setup. And come here, I show you this. Okay, so as we connected here is the function generator, which will be going to the capacitor, and then there is 2 oscilloscope which is measuring the input, and we have supply 10 voltage of DC power supply, and here is another DC power supply. So, and here we got the BJT, bipolar junction transistor, and there is another capacitor. Okay, I will show you guys. There is 2 resistor here. This one is the RC, and this one is the RL, R load. Okay, and there is another transistor right there, another resistor here. Okay, this is the resistor which connected to RE. Okay. So here we are supplying 10 volt for both supplies for the circuit. So that is the supply which makes it goes to the resistor, the both resistor that we showed here, this one and this one. So we will be measuring all these waveforms from the oscilloscope. So this is the oscilloscope which has gain of 80. This is the result that we got 80 gain with the frequency of 1 kilohertz as we done in the multisim previously. So this is the result of the whole circuit. And so this is the oscilloscope we're going to use now. So we connected a wire here for function gen, so it will be supplying a sinusoidal waveform with 1 kilohertz of frequency. And then this is the two measurement probes that we are using to measure the waveform of input, and then there's output. So the input is for yellow color waveform, and the output is for the green color waveform. So this is the wave gen thing which if this is light up, so we are supplying the wave generator from the oscilloscope itself. So this is the run stop button which we'll be using for measure the running waveforms. So we can stop it and then we can play it to see the waveforms exactly. Okay, now we can also use the input amplitude to change the input of voltage input, and then you can see that this circuit will only give amplify the output. So whenever we increase the input, so as the input increases, the output itself also increases. So when the input decreases, the output itself also decreases, but the input is lower than the output because this is a amplifying circuit which makes the output much more bigger, which contain around 80 gain. So this is how will be the waveforms if we make it smaller and higher voltage. Okay, and then but the DC supply will be constant as 10 volt and 10 volt. We just will be playing with the input voltage to change the waveform. Okay, that's all. Now we have seen how does the circuit works. So the circuit contains one BJT which is 2N3904, and then two 1 microfarad capacitor and two 1K resistor and one 360 resistor. So by using this we get this kind of waveforms, output waveform. When we calculate, we will get exactly 80 gain. So that's what we're gonna do, and that's our objective, and we have achieved that objective. Okay, so now we are at the last part of the video. We are heading for the conclusion. Okay, so the conclusion is our objective has been achieved, and we also have learned many things in this project. So first of all, we'll be like starting from simulation. So we have know and learn how to use simulation, and also we have learned how to convert it in Proteus and also PCB board, and in 3D printing layout. And then after that we have heading for etching for PCB board. So we have learned how to do the etching and soldering, and also we have also done the drilling process all. So by doing it, we also know how to follow it step by step by wearing the gloves and also aprons for safety measures, and we have learned some safety measures things. So after that, we also have made for the practical. So for practical, we have learned how to use the oscilloscope and also DC supply and function gen, and how to convert a circuit into a simulation circuit to a realized circuit, and also make it work and work correctly with the gain that we want to achieve. And these are these are the things that we have achieved for this project. And thank you very much, sir, for giving us this opportunity to do this. And we have learned many things by doing practically and also by doing all this. And thank you so much, sir. Thank you for watching.